All right, let's go ahead and get started since we're having a lot of troubles getting started this morning. Everyone doing well?
No.
Wednesday morning?
Yes.
Ready to get going? Okay.
Because I'm in my favorite class, which is sadness class.
Sadness class.
Sadness class.
we
That should be
change
the
his
new
name?
name. Sadness
I mean,
class,
our
yeah.
public speaking.
I mean, data
James
structures, I'm sorry.
speaking with style.
Yes,
Yeah,
I-
same. Are you all taking that?
315 data structures. Welcome to Sadness.
So
So today we're going to talk about two things. One is overloading. Hopefully we'll get into operator overloading, which is actually quite evil. And then we'll talk about templates. Operator overloading basically allows you to redefine all your operators, what plus, multiplication, and pretty much anything else does. Yeah, but we're actually going to do it. And then templates are a way to, it's basically generics from Java, but done inside of C++. Officially, it's how you do parametric polymorphism. And we'll get a little bit into that. Make sure you understand templates because I do that for the rest of the course. Whatever. All right, we talked about that.
Templates enable you to write generic code, create functions and
I don't
class.
like water.
Maybe you should teach this class.
I like
Oh, all right. Function. You stopped. Why'd you stop?
Function and templates used to simplify function overload.
All right, we're doing great.
Like West.
I sent it to you.
Okay, consider the following statements. So this is with operator overloading. Yes. This is a great example. Look at the code. Do you prefer the code on the left or the code on the right?
The right.
You prefer the code on the right.
To the right now, y'all.
It looks simpler.
I actually prefer the code on the left.
To the left.
Why do you prefer the code on the right?
It looks like
Shorter.
it's easier to read.
To the left.
Why do you prefer the code on the left?
Because it actually prints the time.
No, it does. Oh, it does print the time.
Oh. It shows more information.
To the left, to the left.
That, depending upon how the program is structured, can be good or bad. But if we're just looking at the lines of code, to the right.
So if I take my clock and I do plus plus, what am I doing?
Adding to the clock.
What am I adding?
You're adding to the seconds. Clock. So yeah, you're adding
Well, how do you know I'm not adding to milliseconds?
because it says on the left it says my clock dot increment second.
Right, so on the left I'm definitely incrementing the second, but how do you know I'm doing that on the right?
Oh wait, actually, you know what?
When?
If I can answer, I like the one on the left just because the dot equals time, and then to the one on the right has the comparing the pointer, and then the one on the left is.
Oh, but these objects are created on the stack, so we're not comparing pointers.
Yeah. Whoops.
It's okay.
I don't know. I always had the thing with the dot equals. So I always thought, that would compare the values.
So some people like it on the right because it's shorter, and you can do a lot of, shorthand. I prefer shorthand, but okay. Anyway, I prefer the one on the left because it's more explicit on what you're doing. But C++ allows you to do what's on the right. Java, not too particularly, especially since objects can't be created on the stack. So this is why operating overload is needed. Well, that's a total lie.
Did you write that?
No, these are from the book.
Oh.
So when I put down these slides, I'm putting down the author. Sorry, Malik, or whatever his name is.
Oh, you wrote the author.
His name is.
It's Malik, wasn't it? 'Cause-
Oh yeah, he has the same.
yeah.
His first name is the author's last name.
Yeah.
All right, so assignment and member selection are only built-in operations, but you can overload operators in order to give them meaningful values or meaningful meetings, meaningful functions. So most existing C++ operators can be overloaded to manipulate class objects. You cannot create new operators, so you can't come up with new symbols. Sorry. I know.
Sad face.
You mean you can't create a dragon?
You can create a dragon.
In your mind, you can.
I have a new dragon plushie.
Would you want to do it with a bunch of stars? Because I know how we can do that. That was. All right, operator function overloads an operator. Use uses the reserved word operator. Please tell me you give me an example. Okay.
Have you not looked through these?
No.
Yeah, let's be honest.
When the teacher doesn't even know what's on the slides.
No. I just know how it's done. We'll talk about it. It'll work.
Yeah.
That's okay. I had a
You've had the
teacher. I had a history
experience.
teacher in high school that would just Google like history slides, and he would click on it, and he would just talk about whatever popped up.
I've done that for a couple of
You should watch.
classes.
You should have like looked up the history of Japan videos. It's actually pretty.
Once you know the material, it's kind of the slides are just to remind you what to do. All right, syntax. So return type, operator, operating symbol, formal parameter list, or as some people like to pronounce it, parameter list.
Parameter.
You've never heard someone say parameter?
No.
I have.
I would smack them.
Like my mom.
Not really, but
I would.
All right, operator overload. You okay there?
Yeah. I just had some pain in my wrist.
You're having a heart attack.
I know that.
Thank you, Brad.
We're just dying in the middle of your class.
This is, well, you know, it is data structures.
He included items.
Oh, actually, this.
That
Yeah.
makes sense.
All right, include IOStream, int main, int argc, char star arg v, and we'll just return 0. All right, let's see if I can remember the syntax for this. So the return type int, operator plus, we'll have int a, int b, and we'll have it return, I don't know, a times b, because we're like that.
Okay.
Yes.
So let's see if that actually compiled.
Nope.
It didn't compile. Must have an argument of class or enumerated. Oh, yeah, because it has to be a class. So it won't work that way. All right, that was cool. I tried. All right. Let's see if they give me an actual. They're not going to give me a definition? Man, these people are jerks. All right, so you can overload dot star colon question mark size of. You can also, or you cannot overload that. Sorry. You can overload actual star plus equals double equals slash. I don't think you can overload backslash.
How do you override double equals? Just double equals, or double equals.
I'll show you in a bit. Yeah. All right. Can overload for user-defined objects or for a combination of user-defined and built-in objects. So I was surprised it didn't allow me to do it with. Wow. So we already talked about the this pointer. I'm sorry, with built-in primitives. Friend classes. What did I tell you about friends?
It's a great TV show.
No one told you life was gonna be this way.
Should you use friend classes?
Nope.
Yes.
When necessary.
Only when necessary.
I thought you said Fred, and I was like, who's Fred?
All right. Let's go back to our code. Let me see if I can figure out what the problem was here. Int A
Good question.
and B. I know. What is the problem here? Why wouldn't it allow me to do this?
You need friends.
The operator.
Must have an argument of class or enumerated type. So it's implying that I do this, which makes even less sense. Yeah, that's why since that did not make.
Doctor.
Yes.
That did not make.
Maybe you can get rid of the plus.
That doesn't do anything. You need to have that plus right there to tell it what it is.
Okay.
Oh, well, friend class. All right, we're not talking about friends. Wow, these slides are really useless to me. To overload the parentheses and all of that for a class, the function must be a member of the class. Okay, fine. We're going to talk about classes. Silliness. All right, so we'll make a class. What class do you want to do?
Dragon.
Dragon
No, we
class.
already did dragon.
No, it's too late. I already typed it. It's over. Game over. It's over.
Too bad.
I wanted to do unicorn today.
Can we just do fantasy creatures?
Sure. So we have an operator plus, and we'll do that, and we'll just return A. So let's see if that actually compiles. It did. Good. So what am I doing here? What am I doing here? What did I just do here?
Created a class
I created a class.
that has a function.
A public
Operator.
function.
Okay.
plus. So it's changing the plus.
Yeah, so if I go down here and I make a dragon D, it's on the stack, and I go D plus 4, it's going to call this function up here. Watch. Pilot, yay. See? I overloaded plus, so if you did dragon plus an integer, it calls that function.
And why would you want to do this?
Why wouldn't you want to do this? What if you want to overload the subscript operator?
Oh no. Oh no.
Yep. So now it calls the subscript operator when you use the solid brackets. Y'all see what I'm doing?
So is it like overriding the operator itself, or what the operator does?
Yes to both. Those are the same thing.
Okay, so like with that one, if you try to make an array now, it wouldn't make an array.
No, because then you would have an array of dragons. Right now I just have a single dragon. See, if I did, let's see, dragon DS's sub 100, and I did DS sub 50, we'll go ahead and do a it's not going to do anything.
Oh.
No subscript. Oh, whoops. Now subscript on DFs. Because this is an array of dragons, not the dragon itself. And I overrode what the operator does on the dragon itself up here.
So on the dragon itself, but not on the array.
Right, because the array is something different. The array is actually a pointer.
Yeah, cheesecake.
On the other hand,
Never doing this.
I could do this. Ooh, that should give me a null pointer exception. Oh, no, it didn't. Good. Oh, no, because it actually instantiated all 100 on the stack, so it wouldn't do that. Good. So the first subscript went down to the 57th dragon, and then I called the subscript operator with passing in 0. Is that what you think that? Of course, now I have the question, what does that even mean?
Does anything mean?
Yeah, exactly. That's the problem with operator overloading. What does anything mean anymore? What's going on in life? Why are we doing this?
So
Oh, yeah.
you have some sort of
Why would you
cognitive
ever want to overload the operator?
Oh,
Real life example. Why?
oh, let's say, oh, right here's an example. If you want to increment your clock with plus plus instead of calling increment seconds, you can do that. If you want to overload testing equality between two objects, you can do it right there. Another example is, what if you created a matrix object and you want to overload multiplication to do matrix multiplication instead of some weird wacky multiplication that might be built in. So you can do that as well.
So it actually has some use.
Isn't the
Oh, it has a use.
That's just not fair.
I agree with that statement. Yes?
aren't the cout and key-in operators overloaded?
Yes, the instructor and extractor. See, watch. Instructor. I think that's how you. I misspelled that. That's okay. I'm okay with that. DS sub 56. Yep. Go to the 57th dragon and do the instructor operator. Instructor, whatever. Instruction operator, whatever. Instructor. other questions? All right. We're doing great. Where were we? Yeah, we can overload that. We don't care anymore. You could also overload equals. By the way, right now I'm only doing an operator that's passed an integer. You can do it to where it's passed another thing, like, I don't know, a dragon. Oh, it returned 42.
The answer to everything.
That way, I can do ds sub 1 equal ds sub 56. Boom, equals operator. All right. So technically, you're supposed to do it this way.
Technically.
Okay, yeah, you're supposed to do it this way. Find const dragon ampersand a const. There you go. That's what it's supposed to actually look like.
Why does it have a trophy?
Why what? Why are we doing this way? First off, it's a reference, so it does not instantiate a new object. Const, basically telling you that the object is not going to change, because most operators, you don't want to change the operator, you want to return something that's created. And you call the function const because it's not manipulating the dragon itself. So no dragons are being harmed in the execution of this function. If you make it a friend class, you can do it outside of the class. You could look the syntax up for that if you really care. So we talked about those. Actually, I just showed you the insertion and extraction operators.
Yeah.
So you can make it a friend.
All right.
Totally. This is how they actually declared it. If you're going to pass in your new class, so if you wanted to be able to print out your new class using the instruction operator, you could do it this way. Let's go type it, because why wouldn't we? I can never remember it. O-stream, okay. O-stream and...
How much are you using?
Yeah, never. Class? No, it's not class. It should be dragon. Thank you. Const dragon ampersand dude const. All right, enough of this.
Forgot the exiting parentheses.
Everyone's a critic.
Wait, you're using my name?
Whoa! I said critic,
Oh.
not a Craig.
Well, at least you have us here to correct you so your code won't break.
Thank you. I must be really tired. Dragon run. Okay.
What? Oh my gosh.
So if this actually works the first time, which will be impressive, if I try and print out the dragon, nope. Oh, look at this. Here comes the error novel.
Oh no. Oh no. What happened?
So many errors, so little time.
I had that in
Now here we go. Error, friend used outside of a class. Really?
I thought you did it.
That's the error you got.
All right, let's put it in the class. This makes even less sense, actually. Oh my goodness.
Whoa. That
Oh my goodness.
That is lots there.
All right, here we go. O stream not called, right? Because I forgot to put my std in front of it. Hold on. Whoa. Whoa, that was fast. Oh, now we just got one. Cannot have a CV qualifier. Are you serious? Really?
What?
There, finally it worked. So after some headaches, you want to be able to print your class directly out somehow? Here you go. Here's your heading. Put it inside the class, and then you can see out your class. Any questions? Everything makes perfect sense? Great. You can do it with input as well. You can overload assignment. You can do plus plus and decrement. Much better. All right. Are we done with this? Oh my goodness. I showed you.
Let's just move on.
There we go. Good. Any questions about operator overloading? What?
She lost her stress ball.
Any questions about operator overloading? You have to do it probably once or twice in a couple labs, and then that'll be it.
Don't drop us.
But can you see that operator overloading? Well, let's put it this way. So, what's the benefit of operator overloading?
You can change things.
Nothing. Who said that? I was going to give that person an A, but since they didn't speak up, we're done.
You know it's me. It's fine. You know it's me.
No, okay.
Just enough for you to hear it, but not enough for you to think what it is. That's it.
Are the fluorescent lights really that bright?
Yeah,
Yes.
if you look at my eyes right now, they're like really dry. 'Cause I slept with my contacts last night.
Oh, okay.
I hate doing that.
It's like the worst feeling
It's a
right
thing I
now.
don't wear contacts or glasses.
It's made my nose
Yeah,
run.
not something I would
So much.
expect, right? Just did not see it coming. All right. So what's the benefit here? What's good?
You can make your code shorter.
Okay. What's a negative?
You can write
It's-
stuff.
Going around
You
your
can do
elbow.
very bad things with
To
it.
get your butt.
Can this become dangerous?
Yes.
Yeah.
Why? Why?
Because you can overload something and then you need it later.
True. Or your overload operator means one thing to you and another thing to another person, which would be bad.
Sorry.
It's okay. All right, templates. Good. Let's get out of this thing. Git admin. All right. Templates, on the other hand, are very useful.
I'll do it.
And to all those people who love operator overloading, that's fine. I just don't.
Good luck.
Okay, let's increase this to something or another. 12. There we go. All right, templates. So, let's see, what would be a great example here? So a template is used to basically generate a function based on a type. This is similar to Java. But luckily in C++ we can start even simpler. So if we want to template a function, let's pretend we have mult or multiply. There we go. And it takes a constant int a, constant int b. What do you know? We'll make them references. And what should this return? It will return a times b. So we're just trying to multiply two numbers. All right. Obviously, we shouldn't need to write a function for this, but I just want to give you an example of why templating is handy. And we can do standard cout multiply. Now let's do 5 and 7. And then a new line. All right. So we go back here, g plus main.cpp, and then we run it. 35. Okay, great. Now, what if we wanted to do a double. What do we need to do?
We have to change the in multiplier, right?
Well, it just took it.
Why?
Yeah. Oh, yeah. It took it because it coerced 5.2 and 7.8 into an integer, and then did the multiplication.
That's bad.
That's bad.
It should not do that.
No. So what would we need to do?
Cast it.
Create a new function. It's okay. Double. There we go. Compile, run. Now it's actually doing with doubles. Okay? But let's say, but now we have doubles, then we want to do characters, multiply characters or strings. It doesn't make too much sense. Well, things can start getting crazy. So what you can do is you can template on class T. So instead you have multiply, returns a T, it takes two const T. Basically, I'm taking T and replacing it. Now if I, ooh, I didn't take that. Oh, because I put the word template in the wrong portion. Now I wrote one function that generated both.
Oh, we did that.
Oh, you did that in
Java. How
Yes.
we had, how we had T's instead of the O's and all the rest.
T's instead of the O's?
Yeah.
T's instead of objects? So what I did is I parameterized the type that you can pass to this function. So now, given a type T, you can generate a multiply function that takes two of those T types and returns a T. Any questions on what I did just now?
So is the template, is that over everything? I'm just trying to-
That was over, so you put the template right there because overriding the next the function. That's the
It's only the function.
only the function.
Okay, so it's only the next function.
Right. It may actually make more sense for it to be like this at first, because then you see it's all about that function, but the standard way of writing it is this way.
Okay.
All right. Any questions on what I did there? All right. You can also do the same thing with the class. I'm trying to think of how this would work with a dragon. How would this work with a dragon?
What are we trying to do? I can give an example if I know what we're trying to do.
So we want a mythological creature that changes based on its type, whether you send it an integer, a double, a string, a character.
You could have a shapeshifter.
Or a nymph.
Or nymph, yeah.
With a water nymph, you have.
I mean, dragons have different types too, but.
Oh, so you can have an integer dragon and a double dragon?
Well, yeah.
I mean, you can have one with one head and one with two heads.
You can have a fire dragon, a water dragon,
An ice dragon,
Yeah.
forest dragon.
light.
So we're going to use list.
You know,
And I always want to put that opening right there. So class T, and you may have class list of T, and you'll just have, T M elements. M list. There we go. Wow. I'm so used to Java. There we go. All right, let's see if that actually compiles. Not quite, because I didn't put my semicolon after the class. How about now? Not quite. List is not a class template. Wait, what? Oh, that's Java. Ah, Java. On, let's see, expected qualified ID before that. Are the I got to remember the syntax. So that's how you do it with functions. Functions, class declaration. So I typed it incorrectly. Why did I not like T? Oh, because it doesn't want the... I'm so used to Java. Because C++ wants the solid brackets afterwards. There we go. There. Now we have an array. Let's just use pointers like real C++ programmers. And I accidentally quit it. There we go. All right, now let's compile and run. Okay, we're good. So you can make a list. You can do public add const at t at element. And I still put public there. Wow, void. Let's go ahead and make an int imlen. Imlen equals 100. And we'll have imlist equals new. Oh, this has got to be a double pointer. Wow. Okay. Ooh, is it going to allow me to do that? It did. Awesome. So, T is a double pointer. Imlist, we create 100 pointers to T. Set that to imlist, and then imlen is at length. We want to add something. Well, we got to also keep track of the position. Have a double colon? That's fine. C++ is okay with that. I can do this.
Oh no.
Be cool.
Okay.
And then I could even overload the operator const int at ooh. We'll combine everything we learned today, returning a T reference. All right. Let's see if that compiles. It did. Great. So what am I doing here? I'm creating a list of 100 elements of anything of type T. So if we add, we'll just do imlist sub impose, incrementing that equals, what is that going to equal? Element. We'll have it equal to the pointer of element. Great. And then when you want to get it, we'll just return imlist sub. We'll turn the dereference of that. Let's see if that compiles. It did. All right. Oh wait, it's all going to compile until you try and use it. So we can try and create a list of integers. Integer list. Let's see if it compiles. It's still compiled. Man, I'm doing great. And add. Well, for int I equals 0, I is less than 100, I plus plus. We'll go and add a bunch of things to it. I. And then afterwards, will I equals 0, I is less than 100. We'll go and print them out. Not quite. There we go. List was not declared in the scope. Yeah. It wasn't?
You didn't. You just did list I.
Meant IL. And what was the last one? Invalid conversion from constant int pointer to int pointer. What?
Is it not letting you change it because it's a constant?
I'm never changing element. Well, this is not going to compile because you can't convert that way. Oh, conversion from int to int. Oh. So we'll not make it constant anymore. There we go. And then we got to do this. Boom. Ooh, 100.
Why is it 100?
That's a great question. It shouldn't be.
That's a no-no.
That's a bad thing. What happened?
I did 100 times.
Printed 100 times. That's not good. Huh.
Somebody just say rough.
Yeah, exactly. What? So if we do, what if we did 99? It's going to be 99? Oh, it's seg faults.
What?
Oh, it's seg faults. It's seg faulted. Yeah, C++ is like this. Okay, still seg faulting. Ooh, we get to run the debugger. We get to run the debugger.
Oh no.
Easy actually. Sounds like having fun.
GDB a.out. Run. Ah, okay, so it doesn't like it when it tries to print it out. So this guy's causing issues. What if we just do it this way? I didn't think that would work. Oh, we still have to dereference. Why is it not liking that dereference? Let's find out what the issue is. So we'll say position equals pose. I'm going to compile it, see what it is. Okay, or it won't compile. That's cool too. Then segmentation fault. Oh, it doesn't like it when it's 100? Wait a minute. What? Oh, because that needs to stay 100. There we go. Now it won't be seg faulting. That makes perfect sense. But when you add 100, it overwrote everything else, which implies that impose is not actually incrementing. I wonder why that's the case. No, let's get rid of the second part. And impose is incrementing. What is going on? Come on, someone tell me. Imlist at position. Yes, that just occurred. How has this happened?
Said this occurred?
Yeah.
What happened?
That's why I just asked you.
You're the professor.
I am the professor. Y'all should be able to figure this out as well.
Sure.
0, 1, 2. Huh, that doesn't make any sense that this is failing. What is the problem?
Maybe it just doesn't like 100.
Alright, maybe we'll get rid of the pointers. And we gotta get rid of this too, that's what I thought. Boom! Really? That's what it wanted? Okay. I can see why that'd be the case. But we didn't want to do it that way. That's fine. Alright, fine. Alright. So what I did this time is I just created the list of 100 of whatever classes we have. Pose is at 0, len is 100. Every time we add it, we copy everything over to that position particularly. And then we just return it when we ask for it. So I can have a list of integers right here, and then I could also do a list of, that was the wrong key, of doubles. And then I could print it all out as well. Or maybe I can't. Oh, it's not IL, it's DL. Yeah, because, watch.
Oh.
Or maybe not. Function call, add double. Candidate is with T equals double. Oh. Oh, I'm so sorry. This is how C++ sometimes gets you. When it says it can't do it because of the reference, just make the variable set it and then pass it in, and then it's happy. So, huh? Alright. Lots of little things just happened, didn't it? So right here, if you did the compile error, sorry, I went in autopilot, you gotta stop me, guys. No matching function to call list double, add double, blah, blah, blah. The candidate is add T ampersand. So it's looking for a reference. It can't create a reference because right here it's actually creating a temporary variable and passing it to the function. So in order to get around this, you could either not make it a reference, or you can create a temporary variable manually and then pass that variable in. And then I'll be happy about it because now it's actually referencing a variable and it can go on its merry way. But the key thing I'm trying to point out here is that I made one class, list, and I could template it. One was an integer, one was a double. What else could I use? I could do characters, that'd be perfectly fine. I could also do dragon, that'd be perfectly fine. I could also do the built-in string class. That'll be perfectly fine as well. Dragon was not declared in this scope. Really? Oh, I never created the dragon here. There, I created a dragon. Now we're good. But I can make it anything I want, even though I've only written one class. Hopefully everyone here is somewhat familiar with that. Sure, maybe. Alright, we'll do the slides slowly. So a class template, single code segment for a set of related classes called parameterized types. Syntax is template, class type, and then your class declaration. And then when you wake up, you can actually put the types in there. A template instantiation can be created.
See what you did there.
Instantiation can be created with either a built-in or user-defined type. Okay. In other words, you can parameterize what type of type. Wow, this is going to start getting confusing. You're sending to this class. That was the function up here. Here's the class T, sending it to a list. So notice now anywhere I put T is whatever I have up here in the class. So in the example down there where I did list sub int, everything where there's a T is an int. So there's an int right there, an int right here, and an int over here. Any questions? Great. Let's see. Passing a parameter function takes effect at runtime. Passing a parameter to a class template takes effect at compile time. So here's where it gets real tricky. Oh yeah, can anyone tell me why that's tricky? Cannot compile the implementation file independently of the client code. Why would that be bad? Let's go and let me show you what's about ready to happen. Tab, new. We'll make a dragon one for no apparent reason. It'll make no sense, but you know, that's fine. Unicorn. Oh, okay. We'll make a unicorn inside of the dragon HPP file.
They live alongside each other. Might as well. Why do you?
I love those types. All right, so normally we'd have our header file. It would probably look something like this. Template on class T, use T inside the class. And then if we want to implement it, we'd create another file, tab new, dragon.cpp. We'll have it include dragon.hpp. And then when you're trying to implement in a separate CPP file, you would still type everything out like you would normally. You just put template in front of it. So T gets something, unicorn, : get something. So if we go back here, let's see if all that compiles. Was it dragon.cpp? Class unicorn used without a parameter. I think that's why you need the T right there. All right. So when you actually are implementing it, you have to put the T right there. Okay, here comes the problem. Let's say we're inside of main. We'll go ahead and include unicorn.hpp, even though that's not what it is. It's actually dragon.hpp. We're going to get rid of this dragon class, get rid of this dragon list, and make sure everything still compiles. All right, we're good. And now let's try and make a unicorn of type integer. U. It took it. That's amazing. So, it took it normally, and that's what we would expect. But if we were to compile main.cpp into a .o, like this, and then compile the dragon cpp in a .o, like this, and then normally we would just link them together, right? Main.o and dragon.o. And it would link together, right? You remember this from Makefiles?
Nope.
Oh, why did it run? That actually should not have worked. Get some. Oh, because. Oh, you're kidding me. Let me actually call it. Let's try it all over again. There we go. Oh, it's actually going to give us an error right off the bat. So scroll back. Let's call get something on top of unicorn. We try and compile it. We get an error. Undefined reference to get something. Did I misspell it? No. But if I put the implementation right here, and then I try and compile it, oh, it's going to give me a redefinition, which is fine. We'll comment that thing out real quick. Then we'll recompile, and then it runs. In other words, if the definition is not in the header file, as it is in this case, it's not able to compile. Do y'all see what the problem is? Or am I going way too fast? That was a yes to which one?
No, I'm here, got it.
No, seriously, guys. I'm tired too, so that's why I'm in autopilot.
Yeah.
We're dying.
Everybody's talking really quiet. You're barely typing.
Yeah. Okay. Let's look. Main.cpp includes dragon.hpp, right? Dragon.hpp has a class unicorn templated on T, has a function get something.
Yes.
Dragon.cpp has a function called get something. Okay? We'll even have a return m something. There we go.
Return.
Okay, so you would think inside of main you create the unicorn, template on an int, who cares, and then call get something. You should be able to do that, right? Everyone with me so far?
Yep.
All right, but if I try to do that, return was not, hold on.
Yeah.
Did y'all say this and I didn't hear you?
Yes.
How about now? All right, so now we try and compile it, undefined reference to get something. Why? Because when you template, it's not created until it is used. So, inside of main, I try and create the unicorn object, but I don't have the code for it because all I have is the header file. I don't have the CPP. Okay? So the way you do that, there are many ways to get around this. The way I recommend for now is to just include the CPP file in your header file when you're using a template. When using a template. Let me see. And then we do not want to compile that. Let's see what we got. Then you get rid of this, and you would have inside of here if define if def unicorn underscore HPP for being included with the header file, and then we'll go ahead and give you the source code. Otherwise, we're not going to give you the source code. And now when you compile it, it's going to work. It is weird. This is a weird thing with templates in C++. And sadly, no one has fixed this. It's been around since the early 90s, and no one has come up with a clean solution that I have found. If you find a clean solution, please tell me. But I Google it usually every time I teach this course, and I haven't found one yet.
Maybe in the next standard.
Next day.
Did they just release the 14th standard or something?
Yep.
What's the 15th coming out?
I don't know. There was a huge jump between, I think, 99 and 11. So
Really?
it takes it a while sometimes. They have debates, and it's more of an argument, which is really more of a flame war. But anyways,
Is it always a flame war with programmers? Anything else is just arguing?
maybe. All right. So you can put the class definition of the functions into the client code or in the same header. I just showed you to do it the header way. So summary. Oh, good. Operators are reserved words. Praise the Lord, this is over. Operator functions are value returning. Operator overloading provides the same concise notation for user defined types for built-in data types. Yeah, I'm just reading the slides, I know. All right. Oh, wow. Y'all know about the this pointer?
Yeah.
Good.
Yeah. Yeah, we use that a lot.
Don't use friends. They're bad. Friends are bad.
I use this a lot.
Templates are used. They make parameterized types. You can use them on functions.
This is a really long summary.
It really is. I thought a summary would be one slide, but no!
There should not be a summary continued. There's a problem.
That's not a summary.
You can template a function like here, or you can template a class with, for example, with list. And if you template across multiple files, you got to do this weird trick. All right.
Got it.
Good.
Next.
Next.